Hi, good morning, ladies and gentlemen. Welcome to today's webinar on very specifically on NBC Draft Copy 2025, Part 8, Section 2. It has raised a lot of interest among electrical engineers throughout the country. We have over 1,300 registration, which means people love to hear what's happening in the new draft which is coming up, and what are the recommendation as NFE would like to suggest. We just completed yesterday in Cochin, in Coimbatore, well attended by the most of the industry people from Coimbatore. Day before we had a workshop in Cochin. These workshops are supported by initiative of Bureau of Indian Standard, and we are progressing quite well. And I would also wanted to tell you it's a significant moment for the future of electrical safety in India. For the first time, the draft of Part 8, Section 2, electrical installation for the upcoming National Building Code 2025 is open for public review and expert commentary. And we as a professionals, practitioners, and stakeholders have both the right and responsibility to ensure that our regulations reflects current technologies, global best practices, and above all, realities on the ground. This webinar is organized by National Federation of Engineers for Electrical Safety, which is only platform for electrical engineers in the country. It is more than the discussion, it's a call to action to identify gaps, correct if there are errors, and push forward-looking draft and safe and technically sound code that saves lives. Today we have very important speakers, moderator, Mr. Gopakumar, who is also the committee member of Section 2 of Part 8, and he's also the president of NFE. We also have a speaker, Krish Theobald, technical chair of NFE, and is also the member of BAS committee and IEC committee. So very active, Krish, going around the country and training people. And I encourage everyone to participate actively. And this question and answer, whatever comment that you may have, it should be related to today's topic. Do not deviate your questions to other than this draft. And this will be a two-part discussion. Will be on two-part. This is the first part. We may have second part next week or a week after. We have divided because it's such a large subject. So we're going to have two parts in the webinar on part National Building Code. We move on to the next slide. Why you need to join NFE. NFE is a society of electrical engineers and safety professional. If you look at our website, very clearly defined, we are a not-for-profit organization. We have grown as one of the fastest growing society in India. We have over 2,500 members in less than 2 years. And you know what? We have covered 42 cities, physical seminars in 42 cities in less than 2 years. And we have done over 85 webinars from NFE platform. Overall, since last 3 years, we have covered almost 1 lakh plus people connecting either through virtual or physical. It's a huge connect with the country. Our objective is to make our nation electrically safe, make Bharat electrically safe. And we are so happy that most of the chief electrical engineers from various states are also part of NFE. And there are retired people, they're practicing professional, consultant, electricians are part of this NFE. Our vision is very clear: to make every electrical installation free of accident, such as electrocution and fire due to short circuit, and increasing the reliability of electrical installation, that contributing to saving life and property and supporting sustainable development. The mission that every member that drive is to achieve vision through getting accredited of products and personal certification. I once again highlight personal certification, which shall focus on electrical safety by design, manufacturing, installation of maintenance of electrical product, and installed by competent and qualified manpower. We already started our training process. There are EPS schemes, then FLIT programs. We have almost 25, 30 people who already passed these certifications, and we continue. When you go to our website, there are schemes. When you see on the top, we have blogs, we have schemes. In the schemes, you get to know what are the training program that is on calendar. So go to the next page, Lakshmi. So if you look at our membership, very simple. We have individuals, we have corporate, MSME, and student chapter. As I said, the annual fee is only 1,000 rupees, and for corporate, it is 5,000 rupees, and MSME of the price 2,500 is the fee. We have conducted so many workshops, and we have our own guidelines on hospital and all that. So you can download those information from our website, subject to your member of NFE. So those are NFE member can access to these information. Very important presentations on NEC 2023 CA regulations, and the presentation that we have been making in various webinars. It's all available. So as I said, we are honored to have our President Gopakumar, who is very active in ETD 20, ETD 30, and ETD 50, and also is a part of National Building Code Committee. He's also active member in IEC TC64 and TC81 and AC37A. Move on to next page, please. We have Krish, a most young engineer who is traveling with us in almost all the 40 workshops that we have been conducted. His expertise lies on electrical installation design for commercial and large-scale domestic installation. He specializes in achieving on-ground compliance with IEC 60364 based on National Wiring Regulation IS 732 and SP 30. He's also technical director of Protego Plus Electrotech Private Limited. Is a member of BAS ETD 20 and ETD 50. Is a member of IEC TC64, MT1, and MT12. He's also guest faculty member for NEC capsule courses in BIS Training Center at Noida. Move on to next page, please. And myself, I'm Dominic. I'm the host for the day. Move on, please. Yeah, please unshare. So, ladies and gentlemen, it is 11:12 now, and as I said, please, your question answers should be very specific to today's discussion on NBC Part 8, Section 2, and do not deviate the questions to other subject. And this is a Part 1 NBC draft discussion. We'll have Part 2. I leave this platform to our president, Mr. Gopakumar and Krish. Over to you, sir.
Thank you very much, Mr. Dominic, for a very detailed introduction. I think we also are sharing the link for downloading the draft NBC. First of all, as an introduction, I would like to tell all the participants or inform all the participants that, every every document which is made by BIS, it comes for discussion. The W draft means draft for wide circulation, where it is the opportunity of every interested person to make improvements in the document. This means you must read the document, you must understand what it is, and if there are any comments, it is your opportunity to make the comments, and each of the comment is reviewed in the committee, And if it is acceptable, the modifications are made in the standard. So basically, the standards are made with a large consensus of stakeholders. Today in the webinar, what we are going to do is to introduce you how to read some of the sessions of the NBC, and how to comment, or what kind of comments, or how to comment the different clauses, so that it is useful for the committee, or it is useful for BIS to analyze and to improve. Please note that NBC is a very, very important document for the nation. It is used all over. Nowadays, it's becoming very, very important. It is also important that we should ensure that all these standards and regulations are made in a way so that there is no the discrepancies should not occur, or differences should not occur. So I would like to start the first subject which I would like to explain you is from the Central Electricity Authority. I would like to take you to a little bit on a historic, a definition. For example, the Central Electricity Authority Regulations 2023. If you look at some of the requirements, let's say, for example, Chapter 5. Chapter 5 talks about safety provisions of installations not exceeding 650 volt. Similarly, Chapter 6 explains safety provision for installation and apparatus voltage exceeding 650 volt. During our various programs, people used to ask, what is the significance of this 650 volt? To find out the significance of 650 volt, we have to actually look back into little bit into the history of our regulation. For example, I'm sure you're aware that most of the regulations, rules, it started with the British, the information from the British era. I'm just taking you to one of the document which is published in 1906, the Electrician magazine. This was the first document where 650 volt came, or 650 volt is documented in the regulation. For example, what you are seeing in the screen, this was the first wiring regulation published by British in 1882. 1882, the first wiring regulation. This was the first form of any regulation or standard related to electricity, because Britain started producing electricity during this time, and this was the first one. It was just a 3-page regulation. The second one came in 1888. The third one came in 1897. The fourth edition came in 1903, and it carry forward. Nowhere in this regulation a clear definition for voltage was given, except in the 11th edition. 11th edition, which was published in 1908, you can see here, Regulation for Electrical Equipment of Buildings. This was the first document which started writing something. For example, you can see in the sub-regulation, this regulation has some sections which talks about the safety requirement of low pressure, means up to 250 volt, and high pressure up to, that is, above 250 volt. The 11th edition of the regulation, which was published in this was in the 6th edition. Okay, I lost it. As a result of this British regulation, the 1937 Electricity Act, or Electricity Rule, published by the then government, they decided, or they made a definition for voltage, and this was the first definition which came in an Indian document, which is available at the moment. The previous ones were from the British documents. Of course, we were following some of the British informations. Now here, there was no voltage defined during that time. It was pressure. So pressure means difference in electric potential. Now you can see here low pressure. Low, when the nominal pressure not greater than 250 volt and the pressure into exceed 263 volt. Medium means nominal pressure greater than 250 volt and greater than not greater than 650 volt. So there was a definition given. Low means up to 250 volt, medium means 250 to 650 volt, high means 650 above 650 volt. Now, after the independence, in 1956, the IE rule came into existence, and a similar definition has been adopted in IE rule, as you can see in the screen. Then the pressure has been changed to voltage. So here you can see low voltage, the same definition, 250 volt, medium voltage, 650 volt, then high voltage, extra high voltage. Some definitions were given, but 650 volt still continued. Of the reason for continuing this 650 volt, during 1906 or during 1903 to 06, some of the hydel power stations installed in India, they were producing electricity at a voltage of 650 volt. As a result, 650 volt was a significant voltage or an influencing voltage during that time. We are talking about a situation which is 125 or 120 years back. So 650 was like probably, for example, 11 kV, which we call 650 was a significant voltage. Unfortunately, this has been copied, or this has been made as a part of voltage definition in the IE rule 1956. However, IE rule 1956 has been changed to CEA regulation in 2010, where this definition has been removed. Even in the 2000, what you are seeing in the screen is 2023 regulation. In the 2023 regulation, this definition such as low voltage up to 250 volt, medium voltage up to 650 volt, high voltage, these are not there. But still the 650 volt remained. Protection safety measures up to 650 volt, above 650 volt. Basically, there is no reason to keep 650 volt in the regulation. Now, coming back to what kind of standards or what kind of information which we use during the making of the NEC, we made a small research. We tried to different definitions made in different documents which is followed in India. Example, IS 17036, which was published in 2018. This has made some definition. Medium voltage, you can see here, low voltage is up to 1 kV AC, medium voltage is up to 1 kV to 33 kV, then above 33 to 150 kV. In IEV or the 61140, which is a very important standard because this is the fundamental standard for shock protection, they have only two definitions. One is low voltage, next one is high voltage. But sometime in another IEC standard, you can also find a different definition. But more or less, the IEV definition, the IEC definitions remains almost similar, not much change. The IS 12360 gives no name, but voltage bands are given. IEC 60038 may be another way of calling. The Electricity Act 2003 has made a high voltage line, but it told that the authority should define what is this high voltage line. Unfortunately, CEA didn't define this high voltage line. As a result, time being, there is no clear definition for this subject. In IE rule, you can see low, medium, high, extra high voltage. Historically, the 650 volt, as I said, it has come because of the electricity generation at 650 volt in one of the first hydel power stations installed in India. And at that time, 250 volt was used for house wiring or usage in consumer premises. As a result, these voltages came, but probably the best way was to change this 650 at 1956 itself, but it continued. Now, CEA regulation, technical standards for construction and electric plants mentioned as control auxiliary voltage up to 1.1 kV, but this has nothing to do with, and medium voltage above 1.1 kV up to 66 kV. If we go to the state governments, for example, the DERC, Delhi Energy Regulatory Commission, they say low tension up to 230 volt between line to neutral, three phase 400 between lines, high tension 3 phase 11 kV between phases, extra high tension. They have made their own definition. Madhya Pradesh also follows similar to Delhi, whereas if we look at Kerala, Kerala Electricity Supply Code 2014 is making a different definition. Here you can see LT, HT, and EHT. Tamil Nadu again follows almost similar to Kerala, but probably I would say the South India follows something, northern part of India follows something, eastern part of India thing, western part follows another thing. For example, you see here Maharashtra State Regulatory Commission says high tension or HT means all voltages defined as high or extra voltage. Electricity rule means above 650 volt. So low tension means less than 650 volt. Basically, what happens is all over India, different definitions exist. This is one of the confusing subject when we work on a pan-India basis, because South India tells that low voltage means 250, medium voltage means 650, North India says something else, East, West, all differences. During the making of NEC, we consulted with multiple stakeholders, including CEA. Then some informations were taken. Then this presentation, which you are seeing, it was actually prepared during the June 2022, during the making of the NEC 2023. Then we made a proposal to standardize the voltage in this fashion. Voltage nomenclature of commonly used short names of voltage. The class extra low voltage, medium voltage is up to 1 kV to 33 kV, high voltage is 33 to 150 kV, extra high voltage is above 150 kV, and we also decided in principle that we will try to educate about this new definition in NEC to all the regulatory commissions as well as CEA and other organizations, so that one country should follow one rule. All over India, irrespective of east, west, north, south, there should be only one definition. There should be only one rule. That was the idea. Now, coming back to the NEC, for example, the new draft. I'm just showing you the new draft, the wide circulation draft, which is you can see in the screen. Now, scroll down. There is a definition. You can see here the clause number 2.1.179. Here, extra high voltage, extra low voltage, it's okay. Low voltage, voltage which normally exceed 50 volt but not exceed 250 volt. Medium voltage is again 650 volt. The high voltage is 33 kV. Unfortunately, a different definition. This was actually existing in NBC because of the influence 1956 IE rule. Nobody tried to change it so far, and it's time to change. So this is one information which I wanted to give you. Every standard definition is very important because people try to read. Whenever you have a confusion with any of the terms, you should refer the definition, and you should always look at this. Now, unfortunately, this part is one of the place where we can make improvement. As I said, the idea of this webinar is to give you some tips so that all the people, those who are listening, you can also these all these documents are for public comments. You can also read it and you can find out okay, this wording can be improved, and it is the time for people to suggest improvements in the NBC. With this small introduction, I would like to invite Mr. Krish. Krish has been very active in IEC-TC 64 as well as some of the committees in IEC-TC 64, and has been very actively participating in the IEC and IS standard making jobs. And he was also, sometime I would say, he is the best person to ask about the ISO IEC directives and to guide, how a standard has to be made and so on. I would like to invite Mr. Krish. Krish, you can probably share the screen and put your points of how to read, how to draft a standard. Over
Okay,
to you.
thank you. Is the screen visible?
Yes.
So, in whenever a standard is written, an ISO or an IC standard, and this is adopted by several countries as well, there is a directive called ISO IC Directive Part 2, which is the principles and rules for structure and drafting of these documents. because it's very important that all the standards that are written in a consistent manner. So there are a lot of things in this, but I want to highlight a couple important things. See, the first thing is that the standards talk about what's called a performance principle. So if I go to performance principle, it talks about wherever possible, requirements shall be expressed in terms of performance rather than design or descriptive characteristics. So this allows maximum freedom for technical developments. For example,
Probably you can zoom little bit.
yeah, for example, if we talk about a simple standard for something like a table, right? Design requirement would be the table shall have four wooden legs. Now, this is a descriptive requirement, and this is restricting ourselves to making sure that any table that's built according to this standard shall have four wooden legs. But if you write the standard with a performance requirement, according to the performance principle, it says the table shall be constructed such that when subjected to blah, 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 it meets certain stability and strength criteria. The idea here is that because you are specifying performance, not saying that it shall be for, you restrict it to a particular solution, it allows for implementation in many ways. Similarly, in when we talk about electrical standards, we talk about protection against electric shock. The standard doesn't say you shall have automatic disconnection of supply and do this, do this. No, it says you shall provide protection against electric shock. And there are several methods to provide protection against electric shock, be it automatic disconnection of supply, double or reinforced insulation, extra low voltage, so on and so forth. So these standards always follow a performance principle. They provide requirements for performance rather than saying that a particular protective measure or a protective provision shall be used. Then the next requirement is verifiability. See, whenever the standard includes a requirement, this needs to be objectively verifiable. So only these requirements that can be verifiable have to be included. What is an example? See, sometimes you have standards that use phrases like sufficiently strong or adequate strength. These are very vague because what is sufficiently strong for one person may not be sufficiently strong for another person. What is adequately strong for one person may not be strong for another person. So this creates trouble when you have interpretation of standards. So it's very important that you have something that is objectively verifiable. For example, the product shall meet the requirement of a certain test, and the certain test specifies certain forces, and then you have something that is actually strong. Consistency is also very important. So within each document or series of associated document, the numbering should be consistent, should be identical, the wording should be identical, and the same terminology should be used. You shouldn't use synonyms, so in one place, if, for example, you are using a certain word, you can't certainly in another place use a word that is considers it as equivalent to it. Because a simple example is when we talk about RCDs. See, when the term RCD is used, it means an RCCB, an RCB, or CBR or MRCD. But very often we have people saying RCD in one standard, RCCB in one more standard. This is not consistent. This is a very important one, avoidance of duplication and unnecessary deviations. See, it's very important that documents avoid duplication. And this is extremely important when you are referencing things. See, for example, in the National Building Code, we're talking about electrical installations. There are already a series of standards for electrical installations. See, before standardizing any item of subject, the writer shall determine whether an applicable standard already exists. If it is necessary to invoke a requirement that appears elsewhere, this should be done by reference, not repetition. Because in NBC we are providing requirements for electrical safety, they shouldn't, ideally speaking, they shouldn't state the requirements here again. It should just be reference to the relevant standard. This is very important. The reason why this is because when you have a duplication, when one change is made in a particular document, now you have to make the change in the other document as well. And when you duplicate, there's also a chance for errors. By simply referencing, you're solving all these issues. Uh, if we go back to the table of contents, actually, I just go a little further. We talk about verbal forms of expression. This is how we have to explain a requirement, a recommendation, so on and so forth. So when we want to when a standard wants to introduce a recommendation, requirement, permission, possibility, capability, it's very important that the user shall be able to distinguish between these things. And very importantly, requirements need to be distinguishable from the other types of provisions. The idea is that when you want to use a requirement, you only use this kind of wording. If you want to to have a requirement, you say shall. So, for example, an RCD shall be with a rated residual operating current of less than 30 milliampere shall be used. In certain cases, you may say is required to be used, so on and so forth. But the preferred verbal form is shall. If you want to say something shall not be done, you say shall not. It in only very limited cases you can use is not allowed, permitted, etc. So, for example, everything has to be written also in imperative mode. So, for example, switch on the motor, do not activate the mechanism. Very importantly, must shall not be used instead of shall, because shall talks about requirements, must talks about external constraints. That's what we will talk about later on. May not should not be used instead of shall not, because may not is not a prohibition. Shall not is a prohibition. A standard also makes recommendations. So the preferred verbal form is should. So something, for example, uh, you know, I don't know, a particular provision may be a recommendation. It is recommended that is used in certain cases, should not. An example is wiring of these connectors should take into account the wire and cable diameter of the cables defined in the IC 61556 series. So this is a should. A should is a recommendation, a shall is a requirement. For purposes of conformity, only requirements are to be conformed to. Permission. Permission is when you are allowing somebody to do something. So, for example, the preferred verbal form is may, by the way. Example one is IEC 60512-26100 may be used as an alternative to IEC 60512-27100 for connecting hardware that has been previously qualified to this standard. The idea is that when something is allowed, you use the word may. Uh, can and may are two different things. May indicate a permission, can indicate a possibility. What is the difference? See, can or cannot means that use of this connector in corrosive atmospheric conditions can lead to failure of locking mechanism. These measurements can be used to compare different. So may is when you are explicitly allowing a permission, and can is you're saying that this is a possibility to do it this way. External constraint, this is basically not a requirement of the document, and they again for information of the user. The the preferred verbal form here is must. For example, if you are writing a standard for electrical installations and you have a regulation that is having certain requirements, then you use the verbal form must to talk about the provisions of the regulation, because it is an external constraint. Conformity to the must, the external constraint provisions, are not a requirement to show conformity to the standard. They are only there for informational purposes. Now, the last thing I will show you all is what is written in clause 10. And this once again comes up with your references. See, the entire collection of international standards published by ISO and IC is interrelated and forms a system whose integrity has to be preserved. Therefore, references to particular pieces of text should be used instead of repetition to the original source material. Repetition introduces the risk of error or inconsistency and increases the length of the document. It's very important that where you have references, where you are invoking requirements, recommendations, provisions, any provision from another standard, you do this by reference and not by repetition, because when you repeat, it creates A, inconsistencies, and B, when one is updated, then the other is not updated. So many times we have seen in several standards, we have requirements that on the same subject, For example, in the existing NBC, there is you talk about 100 milliampere RCD, but in IS 732 there is no 100 milliampere RCD requirement. If this requirement was invoked by repetition, this is like it was done now, this is the problem. But if you invoke the requirement by reference, then the moment one is updated, the other one is automatically held valid. So this talks about how standards need to be written. And this is very important so that users of the standard understand how these are written and they can consistently interpret the standards. Thank you.
Krish, thank you very much. Krish, I would like to, call your attention to one of the requirement, one of the clause 3.5.2, which talks about the, uh, I would say the, let me show it in the screen. Electrical consultant. Now, if we move down, what is written is, for example, clause number V, state the requirements related to verifying and testing electrical installation. The consultant should write what the electrical, know what kind of verification or testing is required. Is it correct, or what is your opinion in this?
See, this is a clear case of the ISO directives that the standard needs to be improved according to the ISO directives, because it's very simple, right? The job of a consultant, firstly, a consultant term should have not been ideally used, because the job of in an electrical installation, we have a designer, we have an installer, and we have a verifier. The designer may be a consultant, whatever, etc. But the word consultant is actually technically not the right word. This needs improvement here. Now, the designer may be a consultant, whatever, but from a standards point of view, there is a designer. A simple note could have been provided. The designer may be an external consultant or whatever. The requirements related to verifying and testing of electrical installations falls under the scope of the installation of the requirements for electrical installation 732. So it is not the job of the consultant or designer to state requirements relating to verifying and testing of electrical installations. It is the job of the installation, it is job of the standard IS 732. If we look at the ISO IC directives part 2, subclause 5.7 talks about unnecessary deviations, because we want to provide information, and that is, it's a good intention. The standard wants to provide information on this subject, but this information has to be provided in the right place. It is not the job of a consultant or designer to provide requirements for verification and testing. That is the job of the standard. So this is a clear case of an unnecessary deviation.
Okay, thank you, Krish. I would like to, because sometimes people ask, why do we follow the IEC or ISO standards? Now, for your information, what you are seeing in the screen is Indian National Strategy for Standardization, INSS, involving a quality ecosystem. So basically, these are very much related to multiple subjects. So standardization is a very important role. Government has got policies, multiple departments of the government are involved. So if you go through the basic documents, of course, we are supposed to follow certain rules and regulations. Now, for example, in the previous one, in the previous explanation, I tried explaining where the 650 volt came for the first time in India. This is the wiring rule of British, which has come in 1908. As I said, the 1900 to 1906 was the time where the generators of 650 volt was implemented. Then the regulation, you can see here, low pressure not exceeding 250 volt, and the regulation medium pressure exceeding 250 volt but not exceeding 650 volt. So the 650 and 250, all these came from this particular, the fifth edition of IET wiring rule 1908, which was followed in the electricity rule 1937 of India. Now I would like to take you to the next part of our NBC. Please note that we are unable to cover all the subjects of NBC. We are just trying to find out a little bit. As we told, it is the responsibility of every person to read and understand and try to improve the system, or try to make comments so that these can be improved. And now I would like to try. I would like to take you to the clause number 5.3.6, medium or low voltage switchgear and control gear and their assemblies. First of all, this particular requirement, there is an Indian standard existing, which is called as ISIC 61936, part 1, 2, 3, and part 6 for busbar trunking system and so on. So there are standards already existing. Now, the selection of type of medium and low voltage switchgear of any inter alia for any installation, inter alia depends upon the following: voltage of the distribution system, prospective short circuit current at the point at which the switchgear is proposed, prospective short circuit current at which the switchgear is proposed. I think it's repeating, accommodation available and the nature of industry. Okay, prospective circuit current at the point at which the switchgear is proposed and prospective short circuit current. So there are about 5 explanations given in this particular case. Now I am opening the standard IS 61936. Please note that this is an IS standard. Straight away I take you to the annexer C. For example, annexer C. Sorry, I opened a wrong standard. You have to give me a minute. 61439 is the standard. By mistake, I opened another standard. Yeah, 61439. The annexer C user information template. User information template. You can read this very clearly. Table C1 is intended as a template for the identification of items necessary for the assembly manufacturer, which is intended to be provided by the user. Means the customer who is going to buy this panel board, a switchgear or control gear assembly, he has to make this information available to the user. That means the designer, the electrical consultant, is supposed to fill up, you can see here, user requirement. He is supposed to fill up and he has to give this information to the panel builder so that the panel builder, the control gear supplier can make the system useful. Now you see it starts with electrical system. Type of system earthing. You can see here TT, TNC, TNCS, ITTNS, different system earthing are there. The panel board design, the selection of the device, or sometimes some parameters or setting of the parameters of the assembly depends upon the kind of system earthing. Then it goes to nominal voltage, transient over voltage, temporary over voltage, rated frequency, additional site testing requirement. Number 2, the short circuit withstanding capabilities, which starts with sub requirements of about 5. Protection against electric shock, how you are achieving is again subsection 2. Installation, the environment has to be specified. Then I'm scrolling down. There are about 30 plus requirements. Installation method, what kind of installation method? Is it floor mounting, wall mounting, so on. Storage and handling, operating arrangements, maintenance and upgrade capabilities, current carrying capacities, and so on. So basically, to select a switchgear or control gear, the user or the designer, the electrical consultant, is supposed to fill up this entire information. If some information is not applicable, they can put it, okay, NI, not applicable, and give to the user. And this becomes the basic document for the user to understand, or the panel builder to understand what and where this item is going to be used and how, what kind of subjects he has to take care. Now, if this 5.3.6.1, if it gives only 5 items in the list, what happens is generally we misread. We say that, okay, only 5 items are required. Why do I fill up this entire table? So ideally in a standard, instead of giving this 5 items, what it should have been means every switchgear or control gear assembly, the designer, the electrical designer shall provide the filled annexer C to the manufacturer of the control gear assembly, or the protective devices shall be selected based on this particular annexer C. Now this also repeats for, you can see here, switchgear shall have breaking capacity. All over India, we have the habit. We think that in a switchgear control gear, it is only the short circuit current which has to be considered, which is not true. So this is an information which we wanted to give. Probably you can read more and you can write the comments. Now over to Krish. Krish, in some of the sessions, what is your comment on table 1A and 1B? Probably if you can share the screen would be good.
Yeah, sure. Just a second. So this is table 1A. So you see this particular section, it talks about conduit wiring systems. Now, uh, there are, when it comes to table 1A, you see this is talking about the maximum permissible number of single core cables up to and including 1000 nanos that can be drawn into rigid steel conduit. The concern I have with this table is that it has taken a certain standard size of cable and a certain uh, external diameter, and it has done these calculations. However, there are concerns. For example, it says that if you have a 20 millimeter conduit, under so under certain conditions, you are allowed five 1 square mm conductors, and under certain conditions, you are allowed four. Similarly, for 2.5 square mm in 25 millimeter, under certain conditions, you are allowed 10, and under certain conditions, you are allowed 8. This with certain conditions. S talks about where you have a run not exceeding 4.25 meters between blocks and do not deflect by more than 15 degrees, and B applies to runs which deflect from the straight angle by more than 15 degrees. But now there is one problem. In one conduit, you will not only have only one size of cable. For example, you may run two circuits through a conduit. One circuit may be run in 1.5 square millimeter, one circuit may be run in 2.5 square millimeter. This table does not provide any information on that. It only tells us how much you can have of one size. Secondly, 16, 20, 25, 32, 40, 50. These are sizes that are available. There are also other sizes that are available. Sometimes they're 23 millimeters. What about those? Then what about the number of bends? Because as the number of, see, the basic concept of this is that fill factor. You want to ensure that you have ease of drawing of cables. But as you introduce more bends, you introduce more fill factor. The fill factor goes down. This table does not talk about the number of bends at all. So how do you know how many to use when how many conductors you can put in when you have bends? Then lastly, there are nowadays different type of cables available. There are PVC cables, XLP cables. There are in PVC also there are FR, FRLS. These all things have cables have different types of insulations and different thicknesses. What is being considered here? So as you can imagine, this table is once again it is becoming descriptive. It is saying you shall use only these many type of cables. Instead, what would have been much better if, according to the performance principle, the NBC would have simply said, fill factor of 40% shall not be exceeded for one bend, fill factor of or 45% shall not be exceeded for one bend, fill factor of 30% shall not be exceeded for two bends, fill factor of uh, 15% shall not be exceeded for three bends. That way, it is up to the designer to figure out how to figure out the fill factor. And one example could have been given. But instead of being descriptive, a simple performance principle could have been provided that now solves these issues of cable thickness, other sizes of conduit, multiple cable sizes, bend. This table on its own, as you can imagine, is not particularly helpful. Thank you.
Yes, Krish. So that was a good explanation. Krish, if you go to this 5.3.8, before that there is a just above that there is a table. If you can show that 5.3.8. Yes, this you see the colors brown, blue, green, brown, blue. So these are sometimes, by oversight, we every document may have something to improve, and this is an example. For example, here the colors blue, brown has been made. Basically, I think this is from the IET wiring, the British wiring rules. The color coding is followed. So sometimes even 10 people read a document, we may not notice this. So it is important that everybody should read the document and everybody should get involved into this activity and write for the information of the committee members for improvement. Thank you, Krish. I will now share the my screen. Yes, we would like to also take you to the next subject. For example, this one, the clause number 8, section 8, which is talking about earthing. As all of you knows that this earthing is a very, very confusing subject in the country, all over the country. Now, I would like to take you, not everything in earthing we are going to explain, a little bit from the earthing part. Just a moment, please. Different earthing system. Yeah, this one. So here, what is the content? Please note that this content is from the 2016 NBC. Most of this, the contents of this particular clause, this particular session is from the 2016 NBC, which probably need a lot of improvement. The main earthing system of an electrical installation shall consist of an earth electrode, main earth wire, an earthing bar, and an earth electrode, and something is written here. Actually, this was the very old concept. Probably this concept came from these historic documents of 1950s, 1960s. Whereas in the NEC, what I'm showing is in the NEC, we have updated this information to a large extent. Now, a lot of people know that earthing doesn't mean earth electrode. Earthing means how efficiently you are making the equipotential bonding, which was written in all the standards and regulations for decades, but there was a picture missing. Now in the NEC, what you are seeing in the picture is illustration of earthing and protective conductors. Just to explain you how earthing has to be made. Now you are relying upon an earth electrode only in case of a TT system here. If you don't have a TT system, you don't need to have an earth electrode. For example, IS 732, which is the code of practice of wiring. I am taking you to a clause which is 5.5, 5.4. You can see here, 5.4 talks about selection and direction of electrical equipment, earthing arrangement, protective conductors. Now there is a note. You can see this note very clearly. An installation does not need to have its own earth electrode. That means your industry, your house, your installation, your building doesn't need to have its own earth electrode, which is applicable for electrical installation up to 1000 volt AC, 1500 volt DC. That means you have a large industry, you have a transformer outside the building, that is a different thing, but inside the building you are using voltages less than 1000 volt AC, and maybe you have a rooftop solar PV which is maybe 800 volt DC. So in such cases, an installation does not need to have its own earth electrode is the correct the information. If we go to the CEA regulation, Regulation 43 also talks about this particular subject. And for your information, in Regulation 43, a lot of changes happen in the 2023 regulation. For example, this is connection with the Earth, Regulation 43. You can see here, every building shall have protective equipotential bonding by interconnecting the exposed and extraneous conductive parts as per the relevant standard. Here, NEC had made very clearly how you should make equipotential bonding, and it has very clearly written that this requirement has nothing to do with the earth pit. It has something to do with how the basic idea is. Electric shock is not because of potential, it's because of potential difference. In your building, you have a lot of conductive parts. You interconnect or you bond all the conductive parts. As a result, there is no potential difference exist. As a result, there is no shock. Now going back to the CEA regulation again, the old concept, there is a phenomenal change in the CEA regulation in this particular case. For example, what I'm saying, have earth fault loop impedance sufficiently low to permit adequate fault current for the operation of protective device within the time stipulated in the 11 standard. Number 11, again, earth fault loop impedance shall be tested by the supplier. Number 12, earth fault loop impedance shall be of every circuit has to be verified. And for example, if you go to the annexure, let me search multiple places. This earth fault earth fault loop impedance has been included. I'm just searching the annexure in the schedule 2, where the testing of earth fault is also necessary. For example, here, this is the annexure from the CEA regulation. Is protective equipotential bonding tested is one requirement. Is fault loop impedance at the origin of installation is made? Is fault loop impedance at each circuit tested? Is fault loop impedance tested for all sources? So basically, this information or this updation in the NEC happened in sorry, not NEC. This the regulation happened in 2023. Of course, the information about fault loop impedance is not new. It was existing in the standard since 1966 was the first time the fault loop impedance came into existence in the standard. Now, in NEC, we also made some beautiful calculations. For example, the requirement, the earthing of the installation, then the disconnection times are given, then how you should make equipotential bonding. And for example, in TN system, earth fault loop impedance is important for automatic disconnection of supply. The calculations are given. Maximum allowed earth fault loop impedance of MCBs are given. Basically, this information tells you that the correct safety measure against electric fault is protective equipotential bonding and automatic disconnection of supply. Number one, protective equipotential bonding, you must bond every metal part in this fashion, which I have shown, for example, this particular picture. This is number one. And the automatic disconnection of the supply should happen because you have to keep the earth fault loop impedance below certain level. This information was probably not captured very well in the NBC. And now if we read the main reason is from 2016 NBC. This was not, I think nobody looked into this particular chapter. As a result, the contents of this particular session has become, it is little bit problematic. It is so we need a modification of this particular session. Similarly, here, for example, earth enhancing compound. I'm sure all of you are aware about this earth enhancing compound. This compound is nowadays like a fashion. Every customer need a chemical earth. As a result, what they do, they buy this earth enhancing compound and they put it in the earth electrode, try to make research and try to make or reduce the earth pit resistance, and then finally end up with trouble. By the time they are ending up with trouble, nobody, people realizes that it was a mistake, but then it's too late. Now, there is an Indian standard for earth enhancing compound. This requirement of earth enhancing compound. I'm just taking the national forward of this particular standard. This national forward is actually copied from the latest IEC 62305 standard. You can read here. Earth enhancing compounds are effective in soil with resistivity higher than 3000 ohm meter. That means you can use this compound if the resistivity is higher than 3000 ohm meter, means really above rock. You have to use this, not in normal soil. Earth enhancing compounds are not effective in soil with resistivity lesser than 200 ohm meter. In soil with low resistivity, corrosion of the earth electrode shall be considered. And these requirements are very much modified, but still the little bit improvement in this area is required. Earth enhancing compound. Of course, this is not a it is currently the W draft. It is like a requirement, but this need definitely improvement with respect to the latest Indian standard. So with respect to earthing part, I would say since the majority of the information was from the 2016 NBC, this particular session need I would say, a lot of improvement, or probably the entire session can be removed and put to one note, everything shall follow either NEC or IS 3043. So now we would like to take you to one more chapter by Krish. Krish, can you explain a little bit about the verification part?
Yeah, sure. So we'll go through the verification bit. Let me just share the screen. So once again, we have a situation where verification is covered by another standard, which is IS 732, and we have a duplication here. So there, it talks about a lot of different things, but what is particularly concerning is well, in the testing of installations, they talk about some insulation resistance in mega ohms. We don't know where they have pulled out these formulae from. You know, once again, we have inconsistencies. Motors and other equipment, where this formula have come from. Insulation resistance, yes, it has to be done, but once again, this we don't know. This is not what is given in IEC or IS 732 either. Basically, for checking the efficiency of earthing, earth resistance of grid, electrodes connected. This is, well, we don't follow this. You're supposed to verify the protective measure of automatic disconnection of supply by measuring earth fault loop impedance and checking continuity of protective conductors. This is what is given in IS 732. There are other tests as well. For example, there are RCD tests. There are tests for insulation resistance of floors and walls. There are polarity tests. There are phase sequence tests. These have not really been spoken about. There's a lot of scope for improvement here. In you know in the inspection, there are several aspects that have to come into place, not just the stuff they have mentioned here. For example, if we talk about medium low voltage installations, uh there is it here. Now just a second. Yeah. In medium, it should be checked weather, and then it gives a list of things, right? All blocking materials, blah, 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 blah. But if you look at IS 732, which is the actual relevant standard for this, the items that have to be checked are so much more. I mean, this is the full checklist. So, I mean,
Probably you can zoom in, or you can refer which annexer it is. This
okay.
information is available.
So this is in Annex RR of IS 732. It gives a checklist for the various things that have to be checked. There are maybe, I don't know, 100 things here that have to be checked. And then the verification has to be performed according to this report. All of these tests have to be performed. So once again, we have a situation where a standard is trying to cover uh, something, but it should have been done by not by repetition, but by reference. For example, two separate and distinct earth connections are provided for motor and apparatus. This is not this is, once again, this needs to be updated, because you have a case where one document is updated and one is not. Simply by referring, these problems would have been sorted away. So, yeah.
So thank you, Krish. Let me share the screen. Or you are sharing, you are putting something else. You finished, or you are putting
Finished.
something else?
Verification is done.
Okay,
Yeah.
okay. So basically, the contents of this section 9 is basically it need upgradation, is what you wanted to tell. Am I correct?
I think it's important that we don't talk about upgradation, we talk about referencing. I mean, there's no point in just duplicating the content from one standard into this standard, because as we can see, by repetition, when one standard is updated, then the other stays behind. So what actually needs to be done is it should be referenced.
Okay, right. That's a good suggestion. Now, I would like to take the participants to the chapter 11. In chapter 11, there are two pictures existing, as you can see here. Things more than 11 or 60 meters height. So this is one up to 60 meters and more than 60 meters. Now the standard says from 60 meters upwards you need to have a ring and so on. Technically speaking, this pictures, both the pictures are, first of all, it is not from the IEC standard. This picture was existing in the 2016 version of NBC. But I remember we didn't, in the final draft, which was discussed during 2016, this picture was not there. But I really don't know how this picture came into the NBC. I would like to take your attention to the new, also the old ISIC 62305. The subject is air termination against flashes to the side of tall structures. What we should do. Lateral impact of flashes to side of tall structures are considered as negligible for structures up to 60 meters in height measured from ground level. However, elements significantly protruding on facade may be endangered. On structures taller than 60 meters, flashes to the side can occur, especially to protruding parts and corners and edges of the facade. So, some explanations are given in the standard, and in the upcoming standard, some nice pictures are being given how to select, for example, how to avoid flashes to a building where the height is more than 60 meters. You can see some information. So, basically, uh, as I said, we are not referring the entire clause of this particular session. We are just, because if we start referring to entire clause, it takes a lot of time. Just giving you an information for you to take over and to make comment. Basically, this picture is existing in the NBC, but it is not from the IEC. Even as a member of the NBC committee, I really don't know how this picture came into the NBC, because in the final draft, which we discussed during 2015 or 16, this picture was not there. So basically, here we need a lot of improvement. So, Krish, anything, any point you would like to add? One subject I would like to add without referring to any standard is, for example, building classification with respect to electric fire or ignition of fire from electricity, which is a very major subject in the country. A lot of buildings are getting fire. The IS 732 or the IEC 60364-442 explains the protection from thermal effect of electricity. Buildings are classified into BD 1, 2, 3, 4 based on evacuation, and each of these buildings need additional safety measure. For example, BD4, classified as BD4, is the very critical installation where additional safety measure, a lot of additional safety measures are required. We tried to make this classification in one of the standard IS 18732, which was a guide for selecting electrical installation in building. But unfortunately, this information or this information also need to be added in NBC, which will be very much related to the ignition of electric fire. So with this, we try to limit the presentation. We have a lot of questions. Dominic sir, probably we can take up the further things maybe in the next week, part 2 of the presentation webinar. You are on mute.
Yeah, since you're covering, there's one question on the chat box which is I found. Which earthing system should be used in building as per NBC TT, TNCS, TNC, and IT and TNS? So there's a confusion. So since it is covering an NBC, which earthing system should be used in building as per NBC, TT, TNC, or TNC, IT, or TNS? So that is
Yes, unfortunately, this is not defined so far in NBC, whereas in NEC, it's very clearly defined. You can go to, I would say, you can go to NEC Part 1, Section 18. There, for example, industrial and commercial installations, or where you have your own transformer, you are supposed to follow TNS system. And maybe for public electricity distribution, the distribution company can go for TNCS or maybe TT, which is a practice in India. But for the time being, it is not covered in NBC. Probably, we have to write a TNS system for buildings where you have your own transformer or DG, because most of the buildings nowadays have a DG transformer, and avoid this earth pit. Over to you, Dominic.
Yeah, so we have a wonderful participant continuously, sit through. We have almost 1,300 participants, and I would request you to put your question related to today's subject. Okay, I'll take one. Bhavin Shah is saying, as per Gujarat Government Gazette, Class 15, 10.2.c, no kind of any transformer shall be permitted in cellar or basement or within the building, while NBC's the draft saying it is permitted. Can you please clarify the discrepancy between these two? Does it need correction?
Actually, it's very difficult to clarify these discrepancies, because there are so many discrepancies existing in different documents. Uh, so NBC, as all of
Yeah.
us know, it's a guiding document. It is not a mandatory, or it's not of mandatory nature until and unless it is made mandatory by the local government. So it is the Gujarat government to decide whether to follow NBC or to follow their own gazette. So if the government gazette says you should not, or transformers are not permitted, then I think this the government gazette is valid. Over to you, sir.
Okay. Amritlal saying table 1A is taken from old IS 732 in the draft. What they're saying, it is IS 732. Old version is.
Okay, the table 1A and 1B is from the old IS. Thank you, Mr. Amritlal. This is a good information. But anyway, this table is unfortunately not valid as per the new IS 732. Krish, can you throw some light on it?
Sure. I mean, it may very well have been from the old IS 732. So this is once again a reminder that you have to invoke a requirement or any provision by reference, not by duplication, because it was duplicated. Now this has been removed from the new IS 732, but this is still there in NBC. So this now creates a discrepancy. So yeah.
So,
okay.
Chidambar Joshi, on table 1A, if minimum wire size should be 1.5 square mm, why 1 square mm listed in the draft?
Yes.
This has to be taken.
I think this is once again the same situation. I'm not sure what the earlier IS 732 said, but firstly, there are some applications like instrumentation where 1 square mm can be used, but in any case, the standard should not be descriptive. It should just have a performance principle, which is just the fill factor. So,
This is related to building.
yeah,
Krish,
yeah.
NBC is more related to building.
So, but even in a building, you may have some instrumentation circuits, right? Some control circuits. So, for stuff like that. But in any case, like he is right. If as per IS 732, we are not allowed to have lesser than 1.5 square m for certain areas, then we have a problem. And this is once again an area where the requirement should have been invoked by reference, not by provision should have been invoked by reference, not by duplication, because it creates inconsistencies.
There's an interesting question. After achieving the equipotential bonding, can we eliminate the earth weight? Why earth weight Indian standard is still is published?
Oh, I'm so sorry. No Indian standard has published the earth pit. In IS 3043, IS 3043 explains how to make a very good equipotential bonding system. Sometime you may require a earth electrode. Sometime means if you have a TT system, you may require an earth electrode, or maybe a transformer which is near the on the distribution may require an earth electrode. Means it is not under the scope of the final user, it is the scope of the distributor, the electricity distribution company. For such application, you may require an earth electrode, and a typical picture of earth electrode is given in the 3043. It doesn't mean that there is a standard for earth pit exist. So it's just a picture how to make it. But by misinterpreting this requirement, we read it wrong. Over to you, Mr. Downing.
Pradeep Kudare is asking how to interpret this statement from NEC SP 2023 5.5. The continuity resistance of the earth return path through the earth grid shall be less than 1 ohms.
Yes, in 5.5, just after 5.5 of NEC, this particular clause, there is a figure given, figure 3. If you look at the figure, the purpose of the earth grid is given. It's a TNS system, means it's a 5-wire system. You have 3-phase neutral, you have a protective earth conductor starting from the neutral of the transformer to the consumer premise. In addition to that, there is an earth grid. Continuity resistance of grid means from one place to the other place in the earth grid. The resistance of the conductor in the earth grid shall give a resistance lesser than 1 ohm. This has nothing to do with the pit resistance or the resistance to the to the mother earth or mass of soil. The next one, sir.
There are a lot of questions on data center. In Pradeep Mani is asking, in data center, generator neutral and body touch each other during installation due to both are bare earth strip and installations of neutral was damaged during the installation. What is the best practice? A touch of neutral and body earth above the ground is okay? Please suggest.
The best practice is to look at the standard. For example, there is a data center standard available, which is called as IS IEC 22237. For your information, maybe I will just try to show it. 22237 is the standard. Let me open. Data centers, for example, are designed based on ISO 22237. Even though sometimes we follow the TIA 942, or the TIA 942 also starts from this ISO standard 22237, which gives you very clear information what to do. Clause 4 of the standard explains what kind of conformance. Please note that this standard is for the electrical power distribution in data centers. Let me show you the heading of this particular standard. This is power distribution, information technology, data center facilities, power distribution. Clause 4 explains the conformance. Conformance means what kind of must, means what you must follow is the conformance requirement. Power supply requirement, the clause 6, clause 7. Now, you can see here the design of low voltage electrical supply and distribution installations shall be in accordance with IS IC 60364, which is nothing but our IS 732. If you look at the IS 732, there is no need for putting separate running separate GA strip for neutrals, running separate GA strip for body and all. There is a system which is already explained. You must follow strictly the requirement of IS 732. So even in that particular case, for example, in case of a TNS system, or you are supposed to make a TNS system, both the neutral and the body has to be connected to the common earth bus bar. You have to put a large earth bus bar near to the transformer. Both neutral and body has to be connected to the earth bus bar. So,
Okay.
Dominic, sir.
Yeah, Ketan Deshpande is asking, what is the minimum permissible distance of DG set from the building line as per the statutory or best practice guideline?
Okay, here NBC has got a picture. There is a table also which explains the distance between. Let me open up 1 minute, please. There is an annex which explains the distance Okay, Annexer D, additional area required for generator and electric substations. Please have a look at Annexer D. Depending upon the size of the generator, you need to have you need to select the size. Okay, now any more questions? I think we have so many questions.
Yeah, a few more. Yeah, look like Amritlal Nambi has gone through the draft very carefully, and he is suggesting instead of describing 14.2 in NBC, concentrate on 14.4 and similar clauses. So he's giving a recommendation. I think Amritlal should make some comments in the draft as per the BIS prescribed format that has been given. It would be good if you can comment, or probably you can refer to the General Secretary of NFE, because we are collating all the questions and putting forward to them. So that is it. Again, data center NBC 2025, can we mention data center exception, especially for installation of transformer? And DG said at upper floor, as many states have developed data center policy where DG sets are allowed up to fifth floor.
Yes, as all of us knows, NBC is a guiding document. It is up to the state government to make it mandatory or not. If the state government is allowing up to fifth floor by a government order or some kind of document, then that is valid. So the requirement, if NBC is not allowing, it's not valid anymore because the government is overruling that particular requirement.
Rajesh Patel is asking, is any provision for Indian Electricity Act for NEC and CA as guideline for state government, and state government can make more stringent provision but allow NEC and CA regulations?
Legally, I think yes, it is the state governments can. But if you look at the regulation, probably the right person to answer this question is Mr. Apau. I don't know whether he is there in the group.
Yeah, he is
Uh,
there, he is there.
yeah, if you can make Pauser as the host, as the panelist, probably can answer the question.
Yeah, I will ask him. Sir, allowed to talk. Sir, பேசுவீங்களா sir?
Thank you. Am I audible, sir?
Yeah,
Am I audible?
yeah.
Okay, thank you. I am outside, that's why I am asking. Okay, coming to the point, so far we have been discussing with the technical intricacies of all standards. In my opinion, the main point is whether the NBC is making a right thing. Actually, NBC and NEC are mandatory as per CA Regulation 14. But when these two documents are conflicting with each other, what will the end user do? Number one, the end users are architects, consultants, electrical contractors, and implementers are municipal authorities, electrical inspectors, and CA regulations. Ultimately, for example, for the earthing practice, the implementers are electrical inspectors. But NBC prescribes something, electrical inspectors and regulations are prescribing controversial, just opposite to those NBC provisions. Then what will happen if the builder provide a thing which is contrary to the NEC and regulation? Safety certificate will not be issued. So it will become an embarrassment to the builder ultimately. Actually, any standards updation should achieve synergy. That means updation should be there. It should not go into the old standard, reinsert the old standard, obsolete standard. That is happening. For example, GK has clearly advised that fault loop impedance is not taken and earth resistance is taken. So these are the things that we can't give any suggestion to modify. It should be completely scrapped, in my opinion. It will create only a confusion, and the builders, everybody will become is facing embarrassment. For example, one beautiful example I can say, most of the building fires or buildings are availing supply, multi-story buildings are availing supply from distribution transformers. That is, we call it as LVMSBs, low voltage multi-story buildings. As of now, there are no any high voltage equipments like factories and other places. There are no high voltage equipments within the building. Then what's the necessity of providing all the high voltage related measures like nitrogen injection fire protection system and transformer capacities and the oil content, soak pit. So when you touch upon a thing, you just leave it. You just refer NEC or regulation or IS 1646. So there are conflicts between various IS and the NBC. NBC contradicts with NEC, fire protection measures 1646, and the regulation measures of providing for prescribing wrong practices of oil content in substation. These are all the challenges met by the power grid people, and the consensus is not yet evolved so far. But by simply by simply the NBC is providing lot of prescribing guidelines based on textbooks and manufacturers' family. Sorry to say, most of the prescriptions are based on manufacturers' families, based on marketing strategies. I don't know how these things and NBC is become vulnerable to such manufacturers' lobby. I don't know, because it is against the standards, codes, and established practices. If there is anything the NBC can provide is, if there is a conflict between the electrical and the building, that is very well, that can be addressed, because there are people, electrical installers, who is not aware of building facilities. They provide oil-filled transformer in the building. That part, such parts can be clearly. NBC, of course, has brought so many good things. It has banned ESCs and it has prescribed that DG sets should not be placed in the rooftop. These are all good things. These are all applicable for NBC. But providing the earth resistance value and the nitrogen injection fire protection system applicable for the generating plant, these are all quite out of domain, in my opinion. So, sorry, these are my opinion that we people
that
have to
is,
take into account.
Thank
yeah,
you, sir.
ladies and
For the
gentlemen.
information.
Yeah, ladies and
Uh,
gentlemen, that is Kapav Subbaiah, who's the retired chief electrical inspector of Tamil Nadu, highly respected personality in the country, who presented a paper in Japan on behalf of India. Highly knowledgeable, highly learned person who commented on this. Sir, over to you, sir. Gopakumar, you were saying something.
Mr. Amritlal was putting a lot of comments, so I took him into the you can talk, Mr. Amritlal.
Yeah, good
Amrit
afternoon.
Nambi, you
I
can.
think I'm audible.
Yes, you are audible.
Yeah. I just want to make one point, because already there is NEC and other standards specified as per 14.2. And if we go on describing everything in NBC, it is going to create, as Mr. Appav said, now told, it is again going to create more confusions, just like the voltage band. So, as Krish pointed out, it is always better to reference than describing. So, it is always better to reference the concerned standards than to describe each and everything. And NBC should restrict themselves for designing the building, the volume and areas of electrics. Like the electrical room, what should be the electrical room size, and what should be the deck size, and what should be the overall volume of the electrical room, so that the proper ventilations are there, and how to restrict the spread of fire. Similar things should be there. It should not go on describing what is MCD, what is the loop impedance, what is earthing. If they go on describing it, it is going to create more and more confusion, and it going to make our life difficult. That is the one point I have to make.
So Amritlal is from Calicut. He's again a very learned person on these standards. He's also commenting. Similarly, Ramasamy from Institute of Science is also commenting when NEC specify all the electrical requirement, what is the need of repeat of the same in NBC? He is saying my humble and simple suggestion not to publish same matters in different names by the BAS. So there's a couple of recommendations are coming up on the draft. So Appa's commented, Amritlal and Ramasamy also has commented. I'll go to the question to Rajesh
I think
Mehtar.
there is a question from after that, Manoj Gupta. We received a P draft a few months back. The content of P draft and the white circulated draft are completely different. What is the reason? How come BIS published a document with discrepancies is the question. Anyway, we are discussing it, and gentlemen, the W draft published is based on the last 2016 NBC, which need to be modified is the point, and our subject of today's discussion is to request the participants to read the document, the comments, and make comment so that the whole document can be improved. So there is Mr. question from Mr. Rajesh Mehtar. Mr. Rajesh, the question is, what is the distance between two MCC panel as per the clause? Mr. Rajesh, we would request you to, not only that, there were so many questions, about 20-25 questions we just removed from the Q&A, because these questions are of similar nature. All this information are available in the draft. So please go through the draft, then find out rather than trying to get answers, because sometimes multiple places the same informations are there. We request you to go through the standard and read it and understand properly. So, Mr. Dominic, what do we decide? If any of the participants wanted to talk, probably we can take one or two questions and then probably close down the session.
Yeah. If you have any participant wants to come forward and speak, raise your hand. I can allow them to speak online.
Yeah.
So,
Also, there is a question from Mr. Balu G. If an oil-filled transformer is placed near HTLT panel, is a firewall required? Mr. Balu, this is also there in NBC. There is also an IS standard, which is ISIC 61936, which is talking about high voltage electrical installation. ISIC 61936 part 1. This talks about it's a very modern standard which has been taken from IC. It gives a lot of information about the clearances, placing transformers, what kind of firewall is required, what is the height of the firewall, what kind of clearances are required. So probably you can refer to that particular standard. Yeah.
so Ramasamy wants to talk. Yeah, Ramasamy, please go ahead.
Sir, good morning, everyone, sir. Even
Good morning.
Dominic, sir, yesterday itself, I have told you the same thing, sir. Why is there such repetitions from the same house, DAS?
Yeah.
No, do you remember, sir?
Yeah, I did speak.
No,
Then
this is
I
I'm asking time and again, several occasions, several platform I asked. But when NEC is very clearly specifying, why they should confuse and make everyone this thing? We should straight away oppose taking everything in the NBC. And so much repetition, blah, 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 as our Christian told very correctly. Several things are blah, blah, blah only in NBC. Kindly, I will go through and I will give point-wise commentation also, but I will conclude because time is very short.
Thank you. Actually, that is
for permitting me.
Thank you, Mr. Ramasamy. That is what is required. Please go through the clauses and
I will definitely go through. I will comment upon individual. This voltage also I already commented. I already told sir also.
No, you see, telling to us will not work. You have to comment. There is a prescribed format for comments. You have to.
We will do it, sir. I will do it, sir.
Fill up the
Time-bound
format
manner, I will do it, sir. I will do it, sir. Time-bound manner.
Thank you.
Thank you.
So, Dominic sir, we can take probably two more questions. You are on mute.
Yeah, Yogeshwar, you can Please continue.
Probably they can, if you can introduce yourself and then speak, would be good, because most of the time we are not aware who is
Yeah, this is
there.
on record.
Mr. Yogeshwara.
Please go ahead. Okay,
he is not there.
Bhunesh would like to talk. Please talk.
Able to hear me, sir? Now, can you able to hear me?
Yeah.
Yes.
Go ahead.
Yeah, I'm Dr. T. Yogeshwar, retired from JSW Corporate Safety Head. Already my question was there, you answered me, but still I have doubt after having the equipotential, earth is required or not. But achieving the equipotential in the steel industry is, we have seen, very tough. And further, everybody, because I involved investigation of electrical fires, much more. But everywhere we come to the conclusion there is a hot fault, or there may be insulation failure or something. It is called, ultimately there will be a failure of hot fault. ISI design is given. ISI number, I got a book also, and I'm not remembering immediately number. ISI has very well given the earth pit design. But earth pit design, once it is given, you are normally insisting, as I am consultant, insisting that you must have earth pit of this design. But most of the places, earth pits are not designed as per ISI again. So this is a contradictory, because once you have achieved the equipotential, earth pit is not required. If you say equipotential achieved, afterwards the potential difference may established also. It cannot be a constant. Equipotential is not a constant parameter. It will definitely changes depending upon the load. So this is what my feelings are. That's all.
Mr. Ramaswamy, Mr. Yogeshwar, I would like to show you on the screen. You are seeing IS 3043 2018, which is the code of practice of earthing.
Yeah.
Now, in this particular code, there is a picture given, which is a typical way of making an earth electrode. For example, this one, how to make a pipe earth electrode. Now, I hope you are able to see this.
Yeah, absolutely, I can see it.
Yeah. Also, there is a picture.
Yeah, this is there. This is available. You can download. This is available. You have seen it. But basic question is that
For the plate earth electrode. Their standard is talking not to put earth pit, is what I am saying. The picture is just to give an idea that you can make a earth pit if you required as per this figure. It doesn't mean that you must make hundreds of earth pit all around your building, all around your factory, and try to put everything into the earth pit is wrong.
No, that
if you
I
go
fully
to
agree.
no,
I
if you
fully
what you
agree
can
that
do is
statement. I fully agree that statement. How to make the pit out, how many numbers are required, that definitely we understand. But total elimination of the earth pit, it is not possible. That's what I feel.
no, that is up to you. It is possible or not is up to you. What you can do is you can go to clause number 27 of the existing IS 3043. You go to clause 27. Now it explains what you should do. For example, clause 29 I'm taking. This is guideline on earthing of industrial and commercial installation. We are talking about I think a steel industry. You see, I'm reading 27.1.2. The earthing system in the premise of customers of voltage above 230 volt should be designed as a PME system with separate protective conductor. Means you have to have a TNS system. The neutral of the transformer should be connected to the earth electrode by duplicate connection. So this one is there. Now, I would like to, okay, now you see this. As far as the value of earth resistance is concerned, the objective is, from the point of safety consideration, is not to attain a minimum value of earth resistance as is sometimes understood, but the consideration should be whether there is adequate coordination between particularly obtainable value of the earth resistance and setting of the protective relays. Now, if you look at this whole document, for example, I'm just searching earth fault loop. You see, earth fault loop has been explained in 26 places. For example, you see this, the earth fault loop impedance on a reduced voltage. This is for ELV system. Let me go back to one of the previous clauses. So this one, the purpose of earthing is what is written in this particular clause. The purpose of earthing is to provide a low earth fault loop impedance to facilitate automatic disconnection of supply in the event of a fault to exposed conductive parts. And limit the rise of potential under earth fault condition of non-current carrying metal work with respect to earth to increase safety of persons and animals. So these two are the requirements of earthing, which is existing since 1966 is what.
Yeah,
Now,
you're correct, sir. This is the
let's
point
go
of
down.
this is my point of catching from the safety point of view. Earthpit always saves the installation as well as the lives. Of course,
Sorry to tell you that
uh,
it is wrong. Earth pit will add zero safety to you. Therefore, for example, if you have a high voltage installation, you have to reduce the touch and step voltages. To reduce touch and step voltage, what you mean earth pit is a vertical pipe or a plate. Both are not going to help you. You need to have voltage grading. As I said, these standards are based on some information which is too old. Now we are upgrading these standards. A lot of improvements are required. I would like to tell all the participants that the idea of thinking about earth pit and it saves people is wrong. Please remove it from your mind. Fault protection is achieved by protective equipotential bonding and automatic disconnection of supply. So both need to be there. Probably we will have a detailed discussion later on. Thank you very much.
Bonish, if you have, you want to speak, I'll quickly hello. Be sharp and be short on your conversation. Or Veeraraju, I'm allowing you to speak. If you want to address, please go ahead. Okay, sir. Bonish.
Then probably there is no points. Then probably we can close up. There are so many questions. Still, there are a lot of people in listening.
Yeah, we have still 15 questions are there. We will try and answer offline. And we are almost 1 hour 46 minutes. So last question, Viraju who wouldn't talk is saying we should follow only NEC 2023. So or NBC also. So the confusion. I think in next our part 2 webinar we will try and address many of your questions. And also we will have an elaborate discussion on part 2. Maybe next week we'll announce that part 2 NBC draft NBC part 8 and section 2. We will discuss this shortly once again. So till then, please keep commenting. Please, as our Gopal sir said, please go through this draft very carefully. There's a prescribed table are given and you need to comment on that. So thank you so much for joining. The last final word from Gopal sir and Krish, you want to say to the audience anything?
No, as we told, everybody request everybody to go through the document. Please make comments so that the entire document can be improvised. That is the whole agenda of this webinar. Krish, you have any points?
I think from my end, it is just that, standards are written in a certain way, and for ease of use, that's what we should be doing. So yeah, we would encourage everybody to go and comment on the standard. The ISO IEC directives part 2 are freely downloadable on the internet. You can just search to download them. Yeah, thanks.
Thank you, ladies and gentlemen. Please do join NFE as a member. Apart from today's webinar, we have spoken on many technical matters. You can go and download those videos. If you're a member, you get access to many of the technical documents that we have, and also network with entire electrical engineers across the country. Our next workshops is coming up in Udaipur. Then we are coming to Delhi, then Gurugram, that is Gurgaon. So 25th, 26th, 27th. So we'll be doing the workshop on NEC 2023 along with Bureau of Indian Standard. So thank you very much. Wonderful to have you all. We had a record attendees today. And stay safe. God bless you all. Thank you so much. Bye-bye.